Hi everyone. In today's challenge, we are going to solve this problem. The problem name is 01 matrix and the problem number is 542. Alright guys, so first of all, what we are going to do? First of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What are the algorithm logic we are going to use to solve this problem. So everything we will discuss in the logic part. And after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript programming language, I will share a link in the description. You can go through that particular link. You can find all the solution over there. Now, guys, let's see what this problem say, right? So let's understand the problem statement. So, guys, problem say given m cross n binary matrix mat, right? So first of all, we are given with input, right? We are clear with the input. The first input is nothing but we are given a 2D array of m cross n size, and this 2D array is nothing but a binary value, right? Binary matrix. So it will always gonna have either 0 or 1 value, right? I hope it makes sense. What is binary? Binary means nothing but 0 or 1. So this 2D array will either have a 0 value or 1 value in each cell, right? Now return the distance of the nearest 0 for each cell. Now what we need to do? We need to return the distance of nearest 0 for each cell. So return statement is also clear, guys, right? Return statement says we have to return this matrix only, this 2D matrix. We have to return what? We have to return 2D array only. And which array? This 2D array which we are given, right? But what is going to be changed? The each cell is going to tell us now that what is the distance of nearest 0 from that particular cell. I hope it makes sense. If you are not getting, don't worry, guys. We are going to see everything here, right? So now next line says distance between two adjacent cell is 1. So what are the adjacent cell? Let's say this is a cell. If this is a cell, so adjacent cell is going to be top cell, right cell, left cell, bottom cell. So these four cell is going to be adjacent cell for each particular cell, right? So the distance between two adjacent cell is also be 1, right? This is also mentioned, right? Now guys, let's rephrase this one. So first thing in nothing but we are clear one input. We are given one input. We are given a 2D array, or we can say 2D matrix, binary matrix, and we have to return what? We have to return the same 2D matrix where each cell will be telling us that what is the distance of nearest 0 for each particular cell, right? And after that, the distance between two adjacent cell is 1. The distance between two adjacent cell is 1, right? This is the clearly problem statement, right? Now guys, let's see the examples and then try to understand this problem statement in detail, right? So let's see the example. So example says, let's see the first example, right? So this first example, we have given this particular matrix. This is a binary matrix. You can see all the values are 0 or 1. Now what we need to do, we need to find, or we need to return the same matrix, right? So let me write the same matrix here. So I'm going to say this is the same matrix. So what, not 3 cell line. So what we need to do in this matrix, we need to say each cell here, this each cell will telling us that what is the nearest distance, what is the distance of nearest 0, right? So for this first cell, you can see for this first cell, this cell itself is 0, right? So we can say the distance is going to be 0. Same for this, same for this, same for this, right? But for this one, this is not a 0, right? So we here for this cell, we need to find the distance of nearest cell, the distance of nearest 0, right? So if you see the nearest 0 for this cell is nothing but this one, right? This cell has a nearest 0. This cell has 0 value. This cell has 0 value. This cell has 0 value, right? So we can say all the adjacent cell are having a 0 value. That means nothing but if you take any of the cell, you will get a distance 1. So we can say for this cell, the distance is going to be 1, right? So if you consider this one, then also 1. 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 Right? Now let's move to the next cell. For this cell, we are having a 0, 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 because all the cell already having a 0 value. So we don't need to find any nearest 0 cell, right? So you can see in the output as well, 0, 0, 0, 0, 1, 0, 0, 0, 0. And here also 0, 0, 0, 0, 1, 0, and 0, 1, 0, 0, 0. So this is nothing but a simple problem statement. I hope you understood with the example 1. We are given one 2D array, 2D binary matrix. We need to find the distance of nearest 0 for each particular cell, right? If the cell already having a 0 value, we don't need to find, right? We can clearly say 0. If cell has value 1, then we need to find the distance of nearest 0, right? Now let's see the example 1. So not example 1, example 2. And in this example 2, you are going to understand this problem statement in depth. Why? Because there we are going to see some more cases, right? So what I'm going to do, I'm going to say again, write this particular matrix here. Fine. So we have written this matrix here. Now what we are going to do here, we are going to say for this cell, we are going to have a 0 value because this is 0. We don't need to find any nearest 0, right? Because itself it is a 0. Fine. Now we have this 3 or 4 cell which is having a value 1. So for this cell, what is the distance of nearest 0? This is going to be 1, right? Why 1? Because if you consider this one, this is the nearest cell, or this one, it is the nearest cell. So we can say this is going to be 1. You can consider any of 3 nearest cell. Now let's move to the this cell. For this cell, what is the distance of nearest 0? So for this, we can consider this 0, right? You can see this is the nearest 0 which is present to this cell. So and this is at a distance of 1. So we can write here 1. And for similarly for this cell you can see the nearest 0 nothing but this 0 or this 0, right? So you can reach to this 0 by using this direction or by this direction, right? If you're doing this by this two direction, you are getting a nothing but value 2, right? Distance is going to be 2. If you say 1 and 2, 1 and 2, and there are two more ways like 1 and 2 and 1 and 2. So there are 4 bays, but all these 4 bays are giving us a distance 2, right? So we can say distance is going to be 2 here. And for this cell, the distance is 1 because this is the nearest cell, right? So this is the output you are going to get. And in the output as well, you can see 0, 0, 0, 0, 1, 0, 2, 1 to 1. And here as well, 0, 0, 0, 0, 1, 0, 1 to 1. I hope it makes sense, right? So we have seen the problem statement, we have seen the example. Now let's see the constraint as well, right? So you can see in the constraint they clearly mentioned that m comma n always be less than always be greater than or equal to 1. Means there will be at least one cell is going to be present in our matrix. So that means we don't need to check. We don't need to check whether there's cell present or not. Whether we can say we don't need to check the null value, right? If matrix not present, return -1 0. We don't need to do here, right? And second thing, there is at least one 0 is in a mat. Nothing but they are saying that there is always going to be at least one 0 present in our given matrix. And this says that we always gonna able to find out the distance of nearest 0, right? So it will never be a case that for this cell there is no nearest 0 present. It will always be present, right? Because there is always be a 0 present in our matrix. So now we have seen the problem statement. Problem says we are given one 2D matrix, binary matrix, and what we need to return? We need to return a same matrix where each cell will be telling us what are the distance of nearest 0, and also we are also we can say guaranteed that there will be always be present at least one 0 in our matrix, right? Now what we are going to do, we are going to say fine, let's move to the logic part. Let's see how we can solve this problem, right? So what our main motive is going to be here in the logic part, what I'm going to say, I'm going to take this example and I'll try to get this answer 0 0 0 0 1 0 1 to 1 with our logic, right? So first of all, let me write this matrix. So I'm going to say this is my matrix, and here I'm going to write 0 0 0 0 1 0 1 1 1, right? So this is our matrix, right? So what I'm going to do here, I'm going to say find this is our matrix. So one thing we are going to do here, we are going to say just little change I'm going to do here. As you know guys, for 0 we don't need to find actually the nearest distance, right? So what I'm going to say keep it 0 only, right? But for 1 we need to find, right? So let's make it a -1. So wherever we are going to get a -1, that means we need to find there a distance of nearest 0, right? Now what I'm going to do, I'm going to put all these 0 wherever we are getting a 0. We are going to put all these 0 in my queue. So this is my queue, and I'm getting a 0, 0. This is cell number, right? This is location of cell 0, 1, 0, 2, 1, 0, 1, 2. This is nothing but our queue, right? So I have put all these 0 wherever we are having a 0. I have put all these 0 in my queue. Why I have put this 0? Because I am going to use a BFS, breadth first search. And why breadth first search? Because here we need to find a shortest, nearest distance, right? So if you know guys, BFS is simply used to find a shortest path, shortest distance, nearest distance, right? So here our main goal is going to be just try to understand this problem in this way, that from this 0 I need to find the nearest -1, right? So which 0 can let me to reach to -1, right? Which 0? So there are 5 0 present, right? So my main goal is to find the which 0 which help me to get a -1, this cell at the nearest distance. So you'll focus here, right? So let's see here. So we'll understand everything once we go through this particular example, right? So what I'm going to do here, I'm going to take a first of all, let's pop first element which is nothing but 0, 0. We pop 0, 0, and we know 0, 0 is nothing but this cell. So let's move to all the 4 directions and let's try to find out whether we have any -1. So you can see all the 4 direction, top side outer bound, left side outer bound, right side we have 0 not -1, bottom side also we have 0 not -1. So we can say there is no -1 present with this cell. So remove this one and we are not going to do anything with this cell. Now let's move the second cell, the second element which is nothing but 0, 1. Okay, and 0, 1 this one. So do we have -1 for this cell? At the top you can see we don't have any -1. We are out of bound. Left side we are out of bound. Right side we are out of bound. But on the bottom side we have -1. right? On the bottom we have -1. So what I'm going to do, I'm going to say if we are getting anywhere -1, just replace with this with the current cell which was having this cell +1. So it is going to be 0 plus 1 is nothing but 1, right? So we are going to say it is going to be 1. I have it making a sense, right? Once this is done, fine. Now let's move to the next and insert this cell in number q, right? So we are going to say this is nothing but 1 comma 1, fine. Now let's put 0 comma 2. 0 comma 2 is nothing but this cell. So we are going to see whether we have -1 adjacent to this cell. You can see all these four direction, top, right, left, bottom, we are not able to find any -1. It's fine. Now let's move to the next 1 comma 0. For 1 comma 0 this cell, do we have -1? If you go on top, you can say no. Go on right, no. Left, no. But on the bottom, yes, we have -1. So what we are going to do, we are going to say fine, this is going to replace with 0 plus 1. So we can say here is going to be 1. Fine. Now 1 comma 0 is also done. Now let's move to 1 comma 2. So 1 comma 2 is this cell. So do we have -1 with this? So yes, we have -1 at the bottom side. So replace 0 with 1. Right? Because 0 plus 1 is going to be nothing but, let's say 1, right? 1 comma 2 is also done. Now let's as you can see that we have taken this one, right? So we are going to set in our q as well. So we are going to set this q 2 comma 0 and 2 comma 2. So because this cell also we have changes, this cell also we have changed, so we have to insert in my q as well, right? Fine. Now we are going to take a 1 comma 1. So 1 comma 1 nothing but this cell, right? So do we have -1 with this? Yes, we have -1 with the bottom. So we are going to replace this with +1. So 1 plus 1 is nothing but 2. And now you can notice, guys, so we have removed this one, and if you now you're going to take this cell, but you can see if you take this cell 2 comma 0, you will not find any -1. This comma 2 also you will not find any -1. So everything will be removed. Now my q will be empty. Now my q will be empty, so I'm going to return this particular, I'm going to break the loop, and I'm going to return this particular matrix. Return this matrix. And now if you notice this matrix is same as this particular matrix: 0 0 0 0 1 0 1 2 1, 0 0 0 0 1 0 1 2 1, right? So nothing but, let's summarize this one. So we are using a breadth first search where our main target is going to be to find the nearest shortest distance from our 0 node to the -1, right? I hope it making a sense, right? So this is our main goal, from 0 node to the -1, right? We have to find the shortest distance. So we are going to use a breadth first search, and we are going to initially we are going to put all the zeros. After that, whatever the cell we are making changes, we are also putting into our queue, because there may be possibilities, guys. If I just write here 1, if I also just write here 1, if I just write here 1, if I just write here 1, so these all are 1. So this 0 is going to make them to this is going to make changes to this 2 cell, right? But it will not going to change to this cell. So then once we are making changes to this cell, so we have to put in our queue, assuming that they are having they are also a 0, right? Not assume, just directly insert in our queue. If you insert in your queue, then now this will tell us that from this cell we need to find a -1, right? From this cell we need to find a -1. Simple, right? And just the only thing which we are changing, that we are just making, if we are anywhere we are finding a -1, we are saying that in that particular cell what you need to do, you need to replace this cell, you need to replace the current cell +1. Whatever the current cell has a value, +1. Current cell will be telling us that what is the distance of nearest 0, and +1 will tell us that, because this is adjacent to that cell, so +1 tells that what are the what are the distance of nearest 0 from that particular cell, right? Still, if you're not getting, don't worry, guys. If you're still not getting, don't worry. Let's move to the implementation part. Let's try to implement from there, right? So guys, first of all, I'm with the Python, and here what we are going to do, first of all, we are going to define our queue. So queue is going to be nothing but collections .tq, and here I'm going to say number of nodes and number of column as well. So n is going to be number of rows, and m is going to be number of column, right? So once all this thing is done, let me write here q, right? Tq, not u. And once all this thing done, then what we are going to do, we are going to say traverse over this matrix for I in range of and n, let me write n, and for j in range of, let me write j, what I'm putting m, right? So what we are going to say, we are going to say if mat of I and j is equal to 0. If it is 0, then what we need to do, we need to put in our queue, right? So we can say if it is the case, then q would append this I comma j, fine. But if it is not the case, then what we are going to do, we are going to say make this particular cell into -1. That means we need to find the distance of nearest cell for this particular cell, right? Fine. Once this is done, then we are going to use our BFS. So we can say while our q is present, while q have at least one element present, while q has at least one cell present, right? Then this for loop, this while loop will keep going, and here we need to take first element first of all, pop the first element. So how we can pop? We can say old row comma old column is going to be nothing but q dot pop left, right? Q, right? Q U E, but happening right? Q dot pop left. So once this is done, then what we are going to do, we are taking an old row and old column. Now we are going to move to all the adjacent side. So for all adjacent side, we can say for I comma j in 0 comma 1. So this is going to be 0 comma 1 and 0 comma minus 1 and 1 comma 0 and minus 1 comma 0. So these are the four adjacent side, right? Where we can move if this particular current cell. This old row and old column is a current cell. So from this cell, we are going to move to all this four direction, and we are going to say first of all, this current row is going to be nothing but old row plus I, and current column is going to be nothing but old column plus j. If current row is less than 0, or current column is less than 0, or current row is greater than equal to n, or current column is greater than equal to n. So this will tell us that whether it is out of bound or not. If it is out of bound, then what we need to do, we need to continue. We don't need to check, right? And also one more thing, if matrix of this current row and current column is not equal to -1, then also we don't need to check it, right? We are only interested if we have -1 in any of the adjacent cell, right? If it is so, then you have to move here, and here you're going to say fine, in first of all, matrix of this current row and current column is going to be equal to what? Is going to be equal to matrix of old row old column plus 1, right? As we have already discussed, plus 1. Fine. And after that we can say put in this cell in our q dot append this current row and current column. Once this is done, at the end we are going to return this particular matrix. Simple. Let's see whether it's working fine or not. So I believe it should work. Let's see. And you can see both the test case pass. So let's try to submit this code as well. And you can see, guys, it successfully got submitted. So we have done with the Python. Now let's move to the next programming language, which in nothing but we can say C++. So what I'm going to do here, guys, in C++, first of all, we have to define q, right? So q int, not q int, and here we can give a name, let's say q. And after that we are going to say, let's find a length, mat.size, right? And column is going to be mat.0.size. Fine. After doing this, let me just do what I don't know what's happening to it. Right, I'm gonna say now let's move to the all the cell. Check first of all how many zeros are there. For int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, j less than m, j plus plus. And if this mat of I and j is equal to 0, if it is equal to 0, that means nothing but we have to put in our q dot push, right? Q dot push this particular cell. So how we can put? We cannot put integer, right? So let's take it a pair, right? Which will store row and column, right? So we can say q dot push I comma j. Fine. And here we can say if it is not the case, then what you're going to do, you're going to make it a -1. That means we need to find the distance of nearest cell for this particular cell. The distance of nearest 0 for this cell, right? Once this is done, then we are going to use a BFS. For BFS, we can simply say while our q dot empty. While q is not empty, keep moving this particular while loop, and here pop the first element. So we are going to say auto. Our cell is going to be nothing but q dot pop, right? Not pop, right? So q dot front, because pop return a void, right? So q dot front, and after that you can say q dot pop, and then you can say old row. Int old row is going to be cell dot first, int old column is going to be cell dot second, right? And you can say let's make it a array, 2D array, right? So we can say direction array. So we can say direction array is going to be nothing but 0, 1, 0, -1, 1, 0, -1, 0. This is nothing but we can say all the four direction where this we can move, right? We can move to the top, we can move to the right, we can move to the left, we can move to the bottom, right? So we are going to move to each directions. For int I is equal to 0, I less than 4, I plus plus. These are four directions. Now for each we are going to find a current row. Current row is going to be nothing but old row plus direction of I and 1, 0, right? I and 0. Fine. This is going to be current row. Current column is going to be nothing but old row, old plus direction of I and 1. Fine. And old row, not old column. Fine. So now we got a current row and current column. Now we are going to check whether it is out of bound or not. If current row is less than 0, or current column is less than 0, or current row is greater than equal to n, or current column is greater than equal to n, or one more thing, if matrix of current row and column, if it is current row and current column, if it is, we can see if it is not equal to -1, we don't need to traverse over this. So here we are checking simple if we are out of bound, or if we are not out of bound but the cell is not a -1, then we are not interested in that, right? But if it is -1, and if we are not out of one and it is a -1, then we are interested, and we are going to say matrix of this current row and current column is going to be equal to matrix of old row, old column plus 1. And here we're going to say put this particular cell also in our queue. So queue dot push current row and current column. After this, at the end, we are going to simply return our matrix. Let's see whether it's working fine or not. And I believe it should work, right? Let's see. And taking a time, guys. But you can see both the test case passed. So let's try to submit this code, and I believe it will gonna submit. And one more thing, guys, you can define this direction at the top of the while loop as well, right? Fine. You can see, guys, it's successfully got accepted. Now let's move to the next programming language, which in nothing but we can say Java. And in the Java, it is already written something, right? Because I've already solved it. So what I'm gonna do, I'm gonna say, let's make it reset. And what I'm gonna do, I'm gonna say, let's make a queue, right? As you can see, we need to store row and column. So what I can say let's make it a class pair. So class pair will tell us that row and column, right? Row and column. As you know, in C++ we have pair, right? Same thing we are going to define here. Pair will gonna have int row, int column, and here we can say this dot row is gonna be row, this dot column is gonna be column. Fine. So we can do like here. So here what we are going to do in our function, we are going to find our queue. Queue will have this pair as a data type, and the name I'm going to give queue is going to be nothing but queue. So let's make it a name. Fine. Fine. Once this is done, then we are going to find a length. Length is going to be met to length, and int m, which is number telling us that how many columns present for each cell, each row. So they're going to be met to 0 dot length. Fine. Now we are going to say for int I 0, move to each cell. For int I is equal to 0, I less than ni plus plus. For int j is equal to 0, j less than mj plus plus. And here you have to check if matrix of I and j is equal to 0. If it is equal to 0, then what we need to do, we need to push in our queue dot add this new pair of I comma j. But if it is not the case, then make it a -1, because this -1 will tell us that we need to make we need to find the distance of a nearest 0 from this particular cell. Right, now once this is done, then what we are going to do, we are going to use a BFS. We can say simply while this queue dot is empty, while this queue is not empty, so keep moving this while loop, and here of the first element. So for popping a first element, what you can do, you can say pair cell is going to be nothing but what our queue dot, we can use a pop, right? This will directly pop is always as well give us the first element. Once this is done, then we are going to move to the for direction. So we are going to move for direction. So we are going to find this first of all. Int is equal to direction is going to be nothing but 0, 1, 0, -1, 1, 0, -1, 0, and here we are going to say move to all the four directions. So we can say int direction array of this direction. So every time on each direction we are going to get a new cell, right? So we can say int current row is going to be nothing but cell dot row plus d of 0, and the current column is going to be nothing but cell dot column plus d of 1. And here we can say, let me write here int, and here we can say find for first of all check whether it is out of bound or not. If current row is less than 0 or current column is less than 0, let me write 0. Fine. Or current row is greater than equal to m, means it is out of bound. Or current column is greater than equal to m, or matrix of current row and current column is not equal to -1. If any of this case true, that means we are not interested for this particular cell. So we can say directly continue. But if it is not the case, then what we are going to say, we are interested in this cell. We are going to say matrix of current row and current column is going to be nothing but now equal to matrix of old row. Old row is not there, so we can say cell dot row. This is the old row, and cell dot column. So we have to add +1 in this one, right? So now after that we have to push this current row and current column in our queue as well. So we can say our queue dot add new pair of current row and current column. Once this is done, add, then simply you have to return matrix. Right, let's see whether it's working fine or not. And if it is so, let's see first of all. And you can see we got an error. Why we got an error? Because continue is not there. Continue is not there. Why it is not there? So continue is not there. So it's saying that accept is okay. So we haven't put brackets. So do we have missed something? So I just think about it. Current row is less than 0. Current column is greater than 0. Current or why it is 0? Let's see now. and I believe it should work, right? You can see guys, it's passed both the test cases. So let's try to submit this code, and it will definitely submit it. And you can see guys, it's successfully got accepted. Now let's move to the last programming language, which in nothing but because JavaScript. And in the JavaScript, first of all, quickly we are going to get first make a queue. Before instead of queue, we are making simple array. So we can say const give a name queue is empty array, and here we're going to find length. Let const, let's take it a const, and is going to be nothing but let's dot length, and m is going to be nothing but 0 dot length, and here we are going to say fine. Now for move all the direction, let I0 I less than m, I 4, let j is equal to 0, j less than m, j plus plus, and here we're going to say if our mat of I and j is equal to 0, then what we are going to see, we are going to queue the push, we are going to push what, we are going to push this I comma j, right? That means we need to use this in a BFS. But if it is not the case, else what we are going to do, we are going to say make this I of j is nothing but equal to -1, set to -1. That means we need to find distance of nearest 0 for this cell. Once this is done, then we are going to use a BFS. So we are going to say while our queue dot length is greater than 0, keep moving, right? There is at least one cell present, right? So pop that cell, and we're going to say fine. So const old row and old column is going to be nothing but queue dot shift. Once we pop that cell, now what we are going to do, we are going to move to all the direction. 4 int I is equal to 0, not 4. We can simply say, first of all, define a direction. Const direction is going to be nothing but what? Const direction is going to be nothing but 0, 0, 0, 1, 0, -1, 1, 0, -1, 0. Fine. Now once this is done, we are going to move to each direction. So we can say direction dot for each, and here we can say old row and old column, right? And this is going to be nothing but function. So we can simply say this is going to be a function, and in this function what we are going to do, we are going to say fine. So first of all, we are going to say our current row, let current row is going to be nothing but old row plus we can say this is old row, right? So this is I comma j, this should be I comma j. So now what we can say, our current row is going to be old row plus I, that current column is going to be old row plus j, old column plus j. So we got our current row and current column. We are going to check whether it is, so we are going to say if it is greater than equal to 0, and if current column is also greater than equal to 0, and here we can say and if current row is less than n and current column is less than m, and matrix of current row and current column is equal to -1, then only we have to proceed, right? So if it is the case, we are proceeding, and we are seeing that matrix, if we are seeing that matrix of current row and current column is going to be nothing but equal to matrix of old row, that made old row and old column plus 1. So we are making 1 into it. After doing all these things, then we are seeing that push in our queue as well. So queue dot push this particular current row and current column. Once this is done, out of this file loop, we are going to return our matrix. Let's see whether it's working fine or not. And let's see first of all. And you can see we got a wrong answer. Why don't I don't miss E? Alright, so this means nothing but it has not moved to this particular, right? So current row is greater than that, current row is less than n, and current row is less than m, and matrix of current row is equal to -1. So what you have to do, you have to say, you have to add this one. Alright, so we are saying 1, 0, -1, 0, 0, 1. So fine, it is also cool. So it makes sense, right? So everything is working fine, I guess. So why it's saying -1? So let me see. And here as well, I am getting a message. That means nothing but it's not moving here. So while queue length is greater than 0, so you are taking old row and old column, fine, and you are seeing these 4 directions, move to this 4 direction, right? And after that, what you are seeing, current row less than n, current column is less than length, right? Fine, and it makes sense, right? It should work. But if it's not working, then what we can do, we can simply say, don't worry about this, we can simply say for let I is equal to 0, I less than 4, and I plus plus, right? And here we are going to say fine, in this cell we are going to say, in this 4 direction, our current row is going to be nothing but direction of I and 0, direction of I and 1. Fine, now let's say whether it's fine or not. And you can see both the test case passed. So let's try to submit this code, guys. So I hope it should work. Let's see. And you can see guys, it's successfully accepted, right? So we have done the implementation with Python, C++, Java, and JavaScript programming language. If you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.